A Critical History of Greek Philosophy, Part 2, Chapter 8, Chapter I. The Ionics. The earliest Greek philosophers belonged to what in after times came to be called the Ionic school. The name was derived from the fact that the three chief representatives of this school, Thales, Anaximander, Anaximenes, were all men of Ionia, that is to say, the coast of Asia Minor. Chapter 9. Thales. As the founder of the earliest school in history, Thales of Miletus is generally accounted the founder and father of all philosophy. He was born about 624 BC and died about 550 BC. These dates are approximate, and it should be understood that the same thing is true of nearly all the dates of the early philosophers. Different scholars vary sometimes as much as 10 years in the dates they give. We shall not enter into this question at all, because they are of no importance. And throughout these lectures, it should be understood that the dates given are approximate. Thales, at any rate, was a contemporary of Solon. Croesus. He was famous in antiquity for his mathematical and astronomical learning, and also for his practical sagacity and wisdom. He is included in 21 all the accounts of the seven sages. The story of the seven sages is unhistorical, but the fact that the lists of their names differ considerably as given by different writers, whereas the name of Thales appears in all, shows with what veneration he was anciently regarded. An eclipse of the sun occurred in 585 BC, and Thales is alleged to have predicted it, which was a feat for the astronomy of those times, and he must have been a great engineer, for he caused a diversion of the river Halys when Croesus and his army were unable to cross it. Nothing else is known of his life, though there were many apocryphal stories. No writing by Thales were extant even in the time of Aristotle, and it is believed that he wrote nothing. His philosophy, if we can call it by that name, consisted, so far as we know, of two propositions. Firstly, that the principle of all things is water, that all comes from water and to water all returns. And secondly, that the earth is a flat disk which floats upon water. The first, which is the chief proposition, means that water is the one primal kind of existence, and that everything else in the universe is merely a modification of water. Two questions will naturally occur to us. Why did Thales choose water as the first principle? And by what process does water, in his opinion, come to be changed into other things? How was the universe formed out of water? We cannot answer either of these questions with certainty. Aristotle says that Thales probably derived his opinion from observing that the nutriment of all things is moist, and that even actual heat is generated therefrom, and that animal life is sustained by water, and from the fact that the seeds of all things possess 22 a moist nature, and that water is first principle of all things that are humid. This is very likely the true explanation, that it will be noted that even Aristotle uses the word probably and so gives his statement merely a conjecture. How, in the opinion of Thales, the universe arose out of water is even more uncertain. Most likely, he never asked himself the question and gave no explanation. At any rate, nothing is known on the point. This being the sum and substance of the teaching of Thales, we may naturally ask why, on account of such a crude and undeveloped idea, he should be given the title of the father of philosophy. Why should philosophy be said to begin here in particular? Now, the significance of Thales is not that his water philosophy has any value in itself, but that this was the first recorded attempt to explain the universe on naturalistic and scientific principles without the aid of myths and anthropomorphic gods. Moreover, Thales propounded the problem and determined the direction and character of all pre-Socratic philosophy. The fundamental thought of that period was that under the multiplicity of the world there must be a single ultimate principle. The problem of all philosophers from Thales to Anaxagoras was, what is the nature of that first principle from which all things have issued? Their systems are all attempts to answer this question and may be classified according to their different replies. Thus, Thales asserted that the ultimate reality is water, Anaximander are indefinite matter, Anaximenes air, the Pythagoreans number, the electrics being Heraclitus fire, Empedocles the four elements, Democritus atoms, and so on. The first period is thus 23, essentially cosmological in character, and it was Thales who determined the character. His importance is that he was the first to propound the question, not that he gave any rational reply to it. We saw in the first chapter that man is naturally a materialist, and that philosophy is the movement from sensuous to non-sensuous thought. As we should expect, then philosophy begins in materialism. The first answer to the question what the ultimate reality is places the nature of that reality in a sensuous object, water. The other members of the Ionic school, Anaximander and Anaximenes, are also materialists. And from their time onwards, we can trace the gradual rise of thought, with occasional breaks and relapses from the sensualism of the Ionics through the semi-sensuous idealism of the Eleatics to the highest point of pure non-sensuous thought, the idealism of Plato and Aristotle. It is important to keep in mind, then, that the history of philosophy is not a mere chaotic hodgepodge of opinions and theories succeeding each other without connection or order. It is a logical and historical evolution, each step in which is determined by the last and advances beyond the last towards a definite goal. The goal, of course, is visible to us, but was not visible to the early thinkers themselves. Since man begins by looking outwards upon the external world and not inwards upon his own self, this fact too determines the character of the first period of Greek philosophy. It concerns itself solely with nature, with external world, and only with men as a part of nature. It demands an explanation of nature, and this is the same as saying that it is cosmological. The The 24 problems of men, of life, of human destiny, of ethics are treated by it scantily or not at all. It is not till the time of the sophists that the Greek spirit turns inwards upon itself and begins to consider these problems. And with the emergence of that point of view, we have passed from the first to the second period of Greek philosophy, because the Ionic philosophers were all materialists. They are also sometimes called hylists, from Greek hyalou, which means matter. Chapter 10, Anaximander. The next philosopher of the Ionic school is Anaximander. He was an exceedingly original and audacious thinker. He was probably born about 611 BC and died about 547 BC. He was an inhabitant of Miletus and is said to have been a disciple of Thales. It will be seen thus that he was a younger contemporary of Thales. He was born at the time that Thales was flourishing and was about a generation younger. He was the first Greek to write a philosophic treatise, which, however, has been unfortunately lost. He was eminent for his astronomical and geographical knowledge, and in this connection was the first to construct a map. Details of his life are not known. Now, Thales had made the ultimate principle of the universe water. Anaximander agrees with Thales that the ultimate principle of things is material, but he does not name it water, does not in fact believe that it is any particular kind of matter. It is rather a formless, indefinite, and absolutely featureless matter in general. 25. Matter, as we know it, is always some particular kind of matter. It must be iron, brass, water, air, or other such. The difference between the different kinds of matter is qualitative. That is to say, we know that air is air because it has the qualities of air, and differs from iron because iron has the qualities of iron, and so on. The primeval matter of Anaximander is just matter, not yet sundered into the different kinds of matter. It is therefore formless and characterless. And as it thus indeterminate in quality, so it is illimitable in quantity. Anaximander believed that this matter stretches out to infinity through space. The reason he gave for his opinion was that if there were a limited amount of matter, it would long ago have been used up in the creation and destruction of the innumerable worlds. Hence, he called it the boundless. In regard of this innumerable worlds, the traditional opinion about Anaximander was that he believed these worlds to succeed each other in time, and the first a world was created, developed, and was destroyed. Then another world arose, was developed, and destroyed. And that this periodic revolution of worlds went on forever. Professor Burnett, however, is of opinion that the innumerable worlds of Anaximander were not necessarily successive, but rather simultaneously existing worlds. According to this view, there may be any number of worlds existing at the same time. But even so, it is still true that these worlds were not everlasting, but began, developed, and decayed, giving place in due time to other worlds. How now have these various worlds been formed out of the formless, indefinite, indeterminate matter of 26 Anaximander? On this question, Anaximander is vague and has nothing very definite to put forward. Indeterminate matter, by a vaguely conceived process, separates itself into the hot and the cold. The cold is moist or damp. This cold and moist matter becomes the earth. In the center of the universe, the hot matter collects into a sphere of fire surrounding the earth. The earth in the center was originally fluid. The heat of the surrounding sphere caused the waters of the earth progressively to evaporate, giving rise to the envelope of air which surrounds the earth. For the early Greeks regarded the air and vapor as the same thing. As this air or vapor expanded under the action of heat, it burst the outside hot sphere of fire into a series of enormous wheel-shaped husks, resembling cartwheels, which encircle the earth. You may naturally ask how it is that if these are composed of fire, we do not see them continually glowing. Anaximander's answer was that these wheel-shaped husks were encrusted with thick opaque vapor which conceals the inner fire from our view, but there are apertures or pipe-like holes in the vapor crust, and through these the fire gleams, causing the appearance of the sun, stars, and moon. You will note that the moon was on this theory considered to be fiery and not, as we know how it to be, a cold surface reflecting sun's light. There were three of these cartwheels. The first was that of the sun, furthest away from the earth, nearer to us was that of the moon, and closest of all was that of the fixed stars. The wheel-shaped husks containing the heavenly bodies are revolved around the earth by means of currents of air. The earth in the center was believed by Anaximander to be not spherical but cylindrical. Men live on the top end of this pillar or cylinder. Anaximander also developed a striking theory about the origin and evolution of living beings. In the beginning, the earth was fluid, and the gradual drying up by evaporation of this fluid, living beings were produced from the heat and moisture. In the first instance, these beings were of a low order. They gradually evolved into successively higher and higher organisms by means of adaptation to their environment. Man was, in the first instance, a fish living in the water. The gradual drying up left parts of the earth high and dry, and marine animals migrated to the land, and their fins by adaptation became members fitted for movement on land. The resemblance of this primitive theory to modern theories of evolution is remarkable. It is easy to exaggerate its importance, but it is at any rate clear that Anaximander had, by a happy guess, hit upon the central idea of adaptation of species to their environment. The teaching of Anaximander exhibits a marked advance beyond the position of Thales. Thales had taught that the first principle of things is water. The formless matter of Anaximander is philosophically an advance on this, showing the operation of thought and abstraction. Secondly, Anaximander had definitely attempted to apply this idea and to derive from it is the existent world. Thales had left the question how the primal water developed into a world entirely unanswered. Chapter 11, Anaximenes. Like the two previous thinkers, Anaximenes was an inhabitant of Miletus. He was born about 588 BC and died about 524. He wrote a treatise of which a small fragment still remains. He agreed with Thales and Anaximander that the first principle of the universe is material. With Thales, too, he looked upon it as a particular kind of matter, not indeterminate matter as taught by Anaximander. Thales had declared it to be water, and Anaximenes named air as first principle. This air, like the matter of Anaximander, stretches illimitably through space. Air is constantly in motion and has the power of motion inherent in it, and this motion brought about the development of the universe from air. As operating process of this development, Anaximenes named the two opposite processes of rarefaction and condensation. Rarefaction is the same thing as heat or growing hot, and condensation is identifying with growing cold. The air by rarefaction becomes fire, and fire borne aloft upon the air becomes the stars. By the opposite process of condensation, air first becomes clouds, and by further degrees of condensation becomes successively water, earth, and rocks. The world resolves again in the course of time into the primal air. Anaximanders like Anaximander, Anaximenes like Anaximander held the theory of innumerable worlds, and these worlds are, according to the traditional view, successive. But here again, Professor Burnett considers that the innumerable worlds may have been coexistent as well as successive. Anaximenes considered the earth to be a flat disk floating upon air. The origin of the air theory of Anaximenes seems to have been suggested to him by the fact that air is the form of breath, is the principle of life. The teaching of Anaximenes seems at first sight to be a falling off from the position of Anaximander, because he goes back to the position of Thales in favor of determinate matter as first place. But in one respect at least, there is here an advance upon Anaximander. The latter had been vague as to how formless matter differentiates itself into the world of objects. Anaximenes names the definite process of rarefaction and condensation. If we believe, as these early physicists did, that every different kind of matter is ultimately one kind of matter, the problem of the differentiation of the qualities of the existent elements arises. For example, if this paper is really composed of air, how do we account for its color, its hardness, texture, etc.? Either these qualities must be originally in the primal air or not. If the qualities existed in it, then it was not really one homogeneous matter like air, but must have been simply a mixture of different kinds of matter. If not, how do these properties arise? How can the air, which has not in it the qualities of things we see, develop them? The simplest way of getting out of the difficulty is to found quality upon quantity, and to explain the former by the amount or quantity, more or less, of matter coexistent in the same volume. This is precisely what is meant by rarefaction and condensation. Condensation would result in compressing more matter into the same volume. Rarefaction would give rise to the opposite process. Great compression of air, great amount of it in a small space might account for the quantities, say, of earth and stones. For example, their heaviness, hardness, color, etc. Hence, Anaximenes was to some extent a more logical and definite thinker than Anaximander, but cannot compare with him in audacity and originality of thought. Chapter 12. Other Ionic Thinkers. We have now considered the three chief thinkers of the Ionic school. Others there were, but they added nothing new to the teaching of these three. They followed either Thales or Anaximenes in stating the first principle of the world, either as water or as air. Hippo, for example, followed Thales, and for him the world is composed of water. Adius agreed with Anaximenes that it is derived from air. Diogenes of Apollonia is chiefly remarkable for the fact that he lived at a very much later date. He was a contemporary of Anaxagoras and opposed to the more developed teachings of that philosopher, the crude materialism of the Ionic school. Air was by him considered to be the ground of all things. Chapter 13. The Pythagoreans. Not much is known of the life of Pythagoras. Three so-called biographies have come down to us from antiquity, but they were written hundreds of years after the event and are filled with a tissue of extravagant fantasies and the stories of miracles and wonders worked by Pythagoras. All sorts of fantastic legends seem to have gathered very early around his life, obscuring from us the actual historical details. A few definite facts, however, are known. He was born somewhere between 580 and 570 BC at Samos, and about middle age he migrated to Crotona in South Italy. According to legend, before he arrived in South Italy, he had traveled extensively in Egypt and the other countries of the Egypt. There is, however, no historical evidence of this. There is nothing in itself improbable in the belief that Pythagoras made these travels, but it cannot be accepted as proved for lack of evidence. The legend is really founded simply upon the oriental flavor of his doctrines. In middle age, he arrived in South Italy and settled at Crotona. There he found the Pythagorean society and lived for many years at the head of it. His later life, the date and manner of his death are not certainly known. Now it is important to know that the Pythagorean society was not primarily a school of philosophy at all. It was really a religious and moral order, a society of religious reformers. The Pythagoreans were closely associated with the Orphic sect and took form in the belief in the transmigration of souls, including transmigration of human souls into animals. They also taught the doctrine of the will of things and the necessity of obtaining release from it, by which one could escape from the varied round of reincarnate lives. Thus, they shared with the Orphic religious sect the principle of reincarnation. The Orphic sect believed that release from the wheel of life was to be obtained by religious ceremonial and ritual. The Pythagoreans had a similar ritual, but they added to this to the belief that intellectual pursuits, the cultivation of science and philosophy, and in general the intellectual contemplation of the ultimate things of the universe would be of great help towards the release of the soul. From this arose the tendency to develop science and philosophy. Gradually, their philosophy attained a semi-independence from their religious rites, which justifies us in regarding it definitely as philosophy. The Pythagorean ethical views were rigorous and ascetic in character. They insisted upon the utmost purity of life in the numbers of the order. Abstinence from flesh was insisted upon. Although this was apparently a late development, we know that Pythagoras himself was not a total abstainer from flesh. They forbade the eating of beans. They wore a garb peculiar to themselves. The body they taught in the prison of tomb of the soul. The body they taught is the prison or tomb of the soul. They thought that one must not attempt to obtain release by suicide because man is the property of God, the chattel of God. They were not politicians in the modern sense, but their procedure in practice amounted to the greatest possible interference in politics. It appears that the Pythagoreans attempted to impose their ordinances upon the ordinary citizens of Crotona. They aimed at the supersession of the state by their own order, and they did actually capture the government of Crotona for a short period. This led to attacks on the order and the persecution of its members. When the plain citizens of Crotona was told not to eat beans and that under no circumstances could he eat his own dog, this was too much. A general persecution occurred. The meeting place of the Pythagoreans was burnt to the ground, the society was scattered, and the members killed or driven away. This occurred between the years 440 and 430 BC. Some years later, the society revived and continued its activities, but we do not hear much of it after the 4th century BC. It was largely a mystical society. The Pythagoreans developed their own rituals, ceremonial, and mysteries. This love of mystery and their general character as miracle mongers largely account for the legends which grew up around the life of Pythagoras himself. Their scientific activities were also considerable. They enforced moral self-control. They cultivated the arts and crafts, gymnastics, music, medicine, and mathematics. The development of mathematics in early Greece was largely the work of the Pythagoreans. Pythagoras is said to have discovered the 47th proposition of Euclid and to have sacrificed an ox in honor thereof. And there is good reason to believe that practically the whole of the substance of the first book of Euclid is the work of Pythagoras. 34. Turning now to their philosophical teachings, the first thing that we have to understand is that we cannot speak of the philosophy of Pythagoras, but only of the philosophy of the Pythagoreans. For it is not known what share Pythagoras had this philosophy or what share was contributed by his successors. Now we recognize objects in the universe by means of their qualities, but the majority of these qualities are not universal in their scope. Some things possess some qualities, others possess others. A leaf, for example, is green, but not all things are green. Some things have no color at all. The same is true of tastes and smells. Some things are sweet, some bitter, but there is one quality in things which is absolutely universal in its scope, which applies to everything in the universal. corporeal or incorporeal, all things are numerable and can be counted. Moreover, it is impossible to conceive a universe in which number is not to be found. You could easily imagine a universe in which there is no color or no sweet taste, or a universe in which nothing possesses weight, but you cannot imagine a universe in which there is no number. This is an inconceivable thought. Upon these grounds, we should be justified in concluding that number is an extremely important aspect of things and forms a fundamental part of the framework of the world. And it is upon this aspect of things that Pythagoreans laid emphasis. They drew attention to proportions, order, and harmony as the dominant notes of the universe. Now, when we examine the ideas of proportion, order, and harmony, we shall see that they are closely connected with number. Proportion, for example, must necessarily 35 be expressible by the relation of any number to another. Similarly, order is measurable by numbers. When we say that the ranks of a regiment exhibit order, we mean that they are arranged in such a way that the soldiers stand at certain regular distances from each other, and these distances are measurable by numbers of feet or inches. Lastly, consider the idea of harmony. If in modern times we were to say that the universe is in a harmonious whole, we should understand that we are merely using a metaphor from music. But the Pythagoreans lived in an age when men were not practiced in thought, and they confused cosmical harmony with musical harmony. They thought that the two things were the same. Now, musical harmony is founded upon numbers, and the Pythagoreans were the first to discover this. This difference of notes is due to the different numbers of vibrations of the sounding instrument. The musical intervals are likewise based upon numerical proportions, so that since for the Pythagoreans the universe is a musical harmony, it follows that the essential character of universe is number. The study of mathematics confirmed the Pythagoreans in this idea. Arithmetic is the science of numbers, and all other mathematical sciences are ultimately reducible to numbers. For instance, in geometry, angles are measured by the number of degrees. Now, as already pointed out, considering all these facts, we might well be justified in concluding that number is a very important aspect of the universe and is fundamental in it. But the Pythagoreans went much farther than this. They drew what seems to us the extraordinary conclusion that the world is made of numbers. At this point, then, we reached the heart of the Pythagorean philosophy, just as Thales had said that the ultimate reality, the first principle of which things are composed, is water. So now the Pythagoreans teach that the first principle of things is number. Number is the whole ground, the stuff out of which the universe is made. In the detailed application of this principle to the world of things, we have conglomeration of extraordinary fancies and extravagances. In the first place, all numbers arise out of the unit. This is the prime number. every other number being simply so many units. The unit then is the first in the order of things in the universe. Again, numbers are divided into odd and even. The universe, said the Pythagoreans, is composed of pairs of opposites and contradictories, and the fundamental character of these opposites is that they are composed of odd and even. The odd and even, moreover, they identified with the limited and the unlimited respectively. How this identification was made seems somewhat doubtful, but it is clearly connected with the theory of bipartition. An even number can be divided by 2 and therefore it does not set a limit to bipartition. Hence, it is unlimited. An odd number cannot be divided by 2 and therefore it sets a limit to bipartition. The limited and the unlimited become therefore the ultimate principle of the universe. The limit is identified with the unit and this again with the central fire of the universe. The limit is first formed and the proceeds to draw more and more of the unlimited towards itself and to limit it. Becoming limited, it becomes a definite something, a thing. So the formation of the world of things proceeds. The Pythagoreans drew up a list of 10 opposites of which the universe is composed. They are limited and unlimited, odd and even, one and many, right and left, masculine and feminine, rest and motion, straight and crooked, light and darkness, good and evil, square and oblong. With the further development of the number theory, Pythagoreanism becomes entirely arbitrary and without principle. We hear, for example, that 1 is the point, 2 is the line, 3 is the plane, 4 is the solid, 5 physical qualities, 6 animation, 7 intelligence, health, love, wisdom. There is no principle in all this. Identification of the different numbers with different things can only be left to the whim and fancy of the individual. The Pythagoreans disagreed among themselves as to what number is it to be assigned to what thing. For example, justice, they said, is that which returns equal for equal. If I do a man an injury, justice ordains that injury should be done to me, thus giving equal for equal. Justice must, therefore, be a number which returns equal for equal. Now, the only numbers which do this are square numbers. 4 equals 2 into 2, and so returns equal for equal. 4 then must be justice. But 9 is equally the square of 3. Hence, other Pythagoreans identified justice with 9. According to Philolaus, one of the most prominent Pythagoreans, the quality of matter depends upon the number of sides of its smallest particles. Of the 5 regular solids, 3 were known to the Pythagoreans. That matter whose smallest particles are regular tetrahedra, said Philolaus, is fire. Similarly, Earth is composed 38 of cubes and the universe is identified with the dodecahedron. This idea was developed further by Plato in the Timaeus, where we find all the 5 regular solids brought into the theory. The central 5, fire, already mentioned as identified with the unit, is characteristic, believed that the earth is the center of the universe and that everything revolves around it. But with the Pythagoreans, the earth revolves around the central fire. One feels inclined to once to identify this with the sun. But this is not correct. The sun, like the earth, revolves round the circle's central fire. We do not see the central fire because that side of the earth on which we live in perpetually turned away from it. This involves the theory that the earth revolves round the central fire in the same period that it takes to rotate upon its axis. The Pythagoreans were the first to see that the earth is itself one of the planets and to shake themselves free from geocentric hypothesis round the central fire, sometimes mystically called the hearth of the universe, revolved 10 bodies. First is the counter earth, a non existent body invented by the Pythagoreans. Next comes the earth, then the sun, the moon, the five planets, and lastly the heaven of the fixed stars. The curious system might have borne fruit in astronomy. That it did not do so was largely due to the influence of Aristotle, who discountenanced the theory and insisted that the earth is the center of the universe. But in the end, the Pythagorean view won the day. We know that Copernicus derived the suggestion of heliocentric hypothesis from the Pythagoreans. The Pythagoreans also taught the great year, probably a period of 10,000 years in which the world comes into being and passes away, going in each such period through the same evolution down to the smallest detail. There is little to be said by way of criticism of the Pythagorean system. It is entirely crude philosophy of application of number theory issues in a barren and futile arithmetical mysticism. Hegel's words in this connection are instructive. We may certainly, he says, feel ourselves prompted to associate the most general characteristics of thought with the first numbers, saying 1 is the simple and immediate, 2 is difference and mediation, 3 the unity of both this. Such associations, however, are purely external. There is nothing in the mere numbers to make them express these definite thoughts. With every step in this method, the more arbitrary grows the association of definite numbers with definite thoughts. To attach, as do some secret societies of modern times, importance to all sorts of numbers and figures is to some extent an innocent amusement, but it is also a sign of deficiency of intellectual resource. These numbers, it is said, conceal a profound meaning and suggest a deal to think about. But the point in philosophy is not what you think, but what you do think. And the genuine air of thought to be sought in thought itself and not in arbitrary selected symbols. Footnote 3. Footnote 3, Hegel's smaller Logic, translated by Wallace, second edition, page 198. Chapter 14. Chapter IV. The Eleatics. The Eleatics are so called because the seat of their school was at Elia, a town in South Italy, and Parmenides and Zeno, the two chief representatives of the school, were both citizens of Elia. So far, we have been dealing with crude systems of thought in which only the germs of philosophic thinking can be dimly discerned. Now, however, with the Eleatics, we step out definitely for the first time upon the platform of philosophy. Eleaticism is the first true philosophy. In it, there emerges the first factor of the truth. However poor, meager, and inadequate, For philosophy is not, as many persons suppose, simply a collection of freak speculations which we may study in historical order, but at the end of which God alone knows which we ought to believe. On the contrary, the history of philosophy presents a definite line of evolution. The truth unfolds itself gradually in time. Chapter 15. Xenophanes. The reputed founder of the Eleatic school was Xenophanes. It is, however, a doubtful whether Xenophanes ever went to Elea. Moreover, he belongs more properly, 41, to the history of religion than to the history of philosophy. The real creator of Eleatic school was Parmenides. But Parmenides seized upon certain germs of thought latent in Xenophanes and transmuted them into philosophic principles. We have therefore in the first instance to say something of Xenophanes. He was born about the year 576 BC at Colophon in Ionia. His long life was spent in wandering up and down the cities of Hellas as a poet and minstrel, singing songs at banquets and festivals. Whether, as sometimes started, he finally settled at Elea is a matter of doubt, but we know definitely that at the advanced age of 92 he was still wandering about Greece. His philosophy, such as it is expressed in poems. He did not, however, write philosophical poems, but rather elegies or satires upon various subjects, only incidentally expressing his religious views therein. Fragments of these poems have come down to us. Xenophon is the originator of the quarrel between philosophy and religion. He attacked the popular religious notions of the Greeks with a view to founding a purer and nobler conception of deity. Popular Greek religion consisted of a belief in a number of gods who were conceived very much as in the form of human beings. Xenophon attacks this conception of God as possessing human form. And it is absurd, he says, to suppose that God wandered about from place to place as represented in the Greek legends. It is absurd to suppose that the gods had a beginning. It is disgraceful to impute to them stories of fraud, adultery, theft, and deceit. And Xenophon inveighs against Homer, and he saw it for disseminating this degrading conception 42 of the deity. He argues too against the polytheistic notion of plurality of plurality of gods. That which is divine can only be one. There can only be one beast. Therefore, God is to be conceived as one. And this God is comparable to mortals, neither in bodily form nor understanding. He is all eye, all ear, all thought. It is He who, without trouble by His thought, governs all things. But it would be a mistake to suppose that Xenophon's thought of this God as being external to the world, governing it from the outside as a general governs his soldiers. On the contrary, Xenophon identified God with the world. This world is God, a sentient being, true without organs of sense. Looking out into the wide heavens, he said, the one is God. Footnote 4. The thought of Xenophon is therefore more properly described as pantheism than as monotheism. God is unchangeable, immutable, undivided, unmoved, passionless, undisturbed. Xenophon appears thus rather as a religious reformer than as a philosopher. Nevertheless, in as much as he was the first to enunciate the proposition all is one, he takes his place in philosophy, and it was upon this thought that Parmenides built the foundations of Eleatic philosophy. Footnote 4, Aristotle, Metaphysics, Book 1, Chapter 5. Certain other opinions of Xenophanes have been preserved. He observed fossils and found shells in land and the forms of fish and seaweed embedded in the rocks in the quarries of Syracuse and elsewhere. From this he concluded that the earth had risen out of the sea and would again partially sink into it. Then the human race would be destroyed, but the earth would again rise from the sea and the human race would again be renewed. He believed that the sun and the stars were burning masses of vapor. The sun, he thought, does not revolve round the earth. It goes on in a straight line and disappears in the remote distance in the evening. It is not the same sun which rises the next morning. Every day a new sun is formed out of the vapors of the sea. The idea is connected with his general attitude towards the popular religion. His motive was to show that the sun, the stars, are not divine beings, but like others, ephemeral. Xenophon also ridiculed the Pythagoreans, especially their doctrine of reincarnation.